This video is dedicated to the fallen. Because we've had a lot of students fall this week. So,
Like physically fall?
no, like fall.
Like mentally?
No, like,
Fall behind.
yeah, that and maybe the flu and maybe the hospital or something, you know.
I was going to say your names. I was like, go ahead, jump in.
No, we're good. All right, Ms. Moreno, hope you're ready wherever you're at, because she's going to be looking at this video so she can catch up. All right, let's go. Let's start. What we need to focus on this one is those two. So do you agree that this angle here, the A, is half of 2A? Perfect. If you agree that A is half of 2A, which it is, it's a true statement, we can write this. We're gonna say, all right guys, let's lower them on. We're gonna say that cosine of A is equal to 2 cosine squared of half A minus 1. And then I'm gonna move the 1 to the other side, and I'm gonna write the 2 cosine squared first, guys, because that's what I want to solve for. So I'm gonna write 2 cosine squared of half A equals 1 plus cosine A. Are we still okay?
Are you just deriving right now?
Yeah, we're deriving. Divide everything by 2. So cosine squared of half A is equal to 1/2 plus cosine A over 2. I can factor out the half to make it cleaner. So it's going to look like this. 1/2, 1 plus cosine A. Some people don't think that's necessarily cleaner, but that's fine if you don't think that. Not all minds think the same. Then you take the square root to get rid of the square. And then we have cosine half A equals plus minus square root 1/2 1 plus cosine A. And this is something you would probably see on the internet if you were to Google this equation. So I will put that in a nice box like that. Cool, guys?
So what were you trying to isolate? Just cosine half A?
Yeah, we're trying to get a formula for the half angle of cosine half A.
Okay.
All right, so we're gonna do the same thing, but with sine. So here we go. I'm taking my blue pen. I'm gonna do it in blue. I'm gonna use this one here now. So I'm gonna write cosine 2A equals 1. Oh no, I'm not writing 2A. I'm writing A now. Cosine A equals 1 minus 2 sine squared of half A. I'm going to move the 1 to the other side, but I'm going to write the negative 2 sine squared first. Negative 2 sine squared of half A equals negative 1 plus cosine A. And then I want to get rid of the negative 2. So I'm going to divide everything by negative 2, negative 2, negative 2. Sine squared of half A equals 1 minus, 1/2 minus cosine A over 2. And I'm going to factor out the half. Sine squared half A equals 1/2 parentheses 1 minus cosine A. And I'm going to take the square root. So sine of half A is equal to plus minus square root 1/2 1 minus cosine A. How do we feel?
That's the answer.
Yep.
So you're just trying to derive the half angle.
Those are just derivations
Okay.
of your half angles. We're still okay? All right, we're going to derive one more, the tan. And I think we have enough space for the tan. Yeah, we have enough space. So tan of half A is equal to sine of half A over cosine of half A. And I already know what sine of half A is. It's plus minus square root 1/2 1 minus cosine A all over plus minus square root 1/2 1 plus cosine A. Those are the ones that we derived a little while ago. And because we all took Algebra 2 last year with Ms. Torres, I learned this. She told me about law of exponents. And she's like, oh, that square root is just like an exponent. It's like the power to a half. So they both have the power to the half, so I can rewrite this as one giant square root. The halves cancel out, and I can say 1 minus cosine A over 1 plus cosine A. And then from there, I can multiply this by 1 plus cosine A over 1 plus cosine A. And when you do that, in the top, you get the difference of squares. So square root of 1 minus cosine squared A over in the bottom, you just get the same thing repeated. So 1 plus cosine A with a square on it. And because I'm writing square root of something squared, so I can replace 1 minus cosine squared as sine squared. Oh, I left my thought open a little while ago, my bad. And because I'm taking the square root of something that's being squared, I can rewrite this as sine A over 1 plus cosine A.
So that's what the tan is half A.
Yeah, all those are half angle derivations. How do we feel, Mesa? How do you feel, que masa? How do we feel, Claudia? Mesa, que masa, Claudia?
What is that?
Okay.
Wait, I didn't respond.
Yeah, see, she knows what I'm talking about.
Okay.
How do you know? We got this, Vargas?
Yep.
All right, so on the next page, you have your half angles. Bam, bam, bam. Oh, it sounded like that said Pam, right? But I didn't say Pam. Okay, I'll stop. So there they are. So let's go ahead and go right into it, guys. So this one says find the exact value of cosine half A. So cosine half A, I'm going to write cosine half A equals plus minus square root 1, or I guess half first. Put the half in there first. 1 plus cosine A. Do they give me cosine A?
Yes.
Yes, they told me right here that cosine A is 15 over 17. So I'm going to write plus minus square root 1/2 1 plus 15 over 17. And I'm going to turn that 1 into 17 over 17. That 1, I'm going to turn into 17 over 17. So when I do that, you get 1/2 parenthesis 17 plus 15 is 32 over 17. And we know that 2 goes into 32 16 times. So now we can write it like this. We can say plus minus square root, and we can write 16 over 17, which equals plus minus square root of 16 over square root of 17. And the square root of 16 is 4. And then if you want to rationalize it, you can. Plus minus 4 square root of 17 over 17. Now here comes the moment of Jesus. Is this positive or is this negative? This function, this answer. Can't be both. It has to be one.
Positive.
You think it's positive?
I think.
All right. So let's see. Why do you think it's positive?
Because. Oh wait, no. It's. Is it negative because of the interval?
What's my interval?
270 to 360.
You're telling me that cosine is negative on 270 to 360?
Okay, positive. It's positive.
Well, A is positive for cosine 270 to 360. Do I have angle A? Or do I have angle, or am I looking at angle half of A?
Half of it.
That's right. What's half of 360?
180.
What's half of 270?
135.
And between 135 and 180, is cosine positive or negative?
Cosine is x.
Cosine is x.
I don't know. It's what negative.
It's negative. Thank you, Jesus. It's negative, guys.
So we have to take half of the interval it gives us.
Mm-hmm. Yeah, the interval is between 270 and 360, but I don't want angle A. I want angle half A.
Right. No, to find out if it's positive or negative.
Correct. Yep. To find out if it's positive or negative, you got to look to see what quadrant you lie in. All right. So cosine 2A. So this is similar to your exam. It's pretty basic. For cosine 2A, we're going to use the cosine formula. So cosine 2A is equal to 2 cosine squared of angle A minus 1. And they already gave us cosine squared of A. So I'm going to write 2 times, what was it, 15 over 17? 15 over 17 squared minus 1. So we have 2 times 15 squared is 225. That's easy to know. 17 squared, I want to say 289 minus 1. So now we're going to double the 225 because the 2's outside. So double the 225, you get 450 over 289 minus 1. And then we're going to turn that 1 into 289 over 289. So 450 over 289 minus 289 over 289. So you can approximate that by subtracting 300 and then just adding 11. So 450 minus 3. 350, 250, 150, 150 plus 11, 161. And there you go. How do we feel? That's how we feel, right? Kamasa, do we feel okay over there? What about Flavia? How am I so funny? I'll stop. All right. Verify your answers numerically by calculating the values of 2A and half A.
Wait.
Oh,
Why
what's up?
isn't it negative?
Oh, that's it. It's not negative because the 450 is bigger than the 289.
But
This one doesn't have a plus minus. No, this is double. This is not half angle. This is double my angle.
Oh, yes.
So I'm going to lie somewhere. I'm either going to be in quadrant 1 or quadrant 4. Okay. So this one says verify your answer numerically by calculating cosine 2A and half A and finding the cosine. So we're going to do this with a calculator. So look up there. So I'm going to find the inverse of cosine. And I'm going to push 15 over 17. And it's going to tell me my degree. So 28 degrees. But the calculator is dumb. It does not know that we're in quadrant 4. That angle A is in quadrant 4. So I'm going to force it to be in quadrant 4. 360 minus that angle. So there it is. And I'm going to store it to angle A. We still okay? All right, check this out. I'm going to write cosine 0.5 alpha A. That's half A, right? I'm going to push enter. And I get that number, negative 0.9701. I want to know, is 4 divided by square root of 17 that number? Let's see. 4 divided by square root of 17. Yes, I know I forgot the negative, but just put the negative in there. And look at that. It's the same, digit per digit. So did we get it right? We got it right. Now let's try the other one, the double angle. So cosine 2A. Cosine 2 alpha A. Enter. I get 0.557. Let's see if 161 divided by 289 is that. And there it is. It is. There's something funny going on with the last digit, but yeah, there it is. Cool or not cool? Yeah, we're good. Let's keep going. All right, so these are the type of questions you're going to see online. And if you would have gone to Houston, you probably would have seen one of these on a Saturday. So here we go, guys. We can do this without a calculator. So the first thing I would do, I guess if you're a smart test taker, this is x over 2. So the first thing I would do is this. Angle x over 2 falls between 135 degrees and 90 degrees. And then I would say, is cosine positive or negative between 90 and 135? It's in quadrant 2, cosine.
No, negative.
Negative. Delete, delete, delete. It's between D and E. I guess it could be F. So look, you automatically make your choices, like your choices for guessing correctly now just jump extreme. Cool? All right, next. Cosine of x over 2 is plus minus square root 1/2 1 plus cosine of x. They already give you cosine x, it's negative 1/7, so I'm just going to plug in. Plus minus square root 1/2 1 minus 1/7. It's minus because it's a negative, so it's plus a negative. And then when I do that, 1/2 parenthesis 1 minus 1/7, so that's like 7 over 7 minus 1. So that's 6/7. See? And then 2 goes into 6 3 times. And now we can say plus minus square root of 3 over square root of 7. And then I'm going to multiply both sides by the square root of 7 over the square root of 7. And then you get plus minus square root of 21 over 7. And we already said that this was going to be negative, so negative. So the answer is that one. Mm-hmm. Yes, we're talking to Miss McLaren? Yeah, that's fine. Cool or not cool, guys? Okay. Flavia? Yeah, you're Eliana, and you're Mesa, and you're Kamasa, and Flavia. Okay. All right, here we go. So sine of x over 2. They're all acute, so that doesn't help me because they're all positive, so I can't cancel anything out. All right, so that trick that we used in the last one won't work on this one. And now let's figure out this one. So sine of x over 2 equals plus minus. Well, we already know it's going to be the positive, but it's just make it a habit. 1/2 parenthesis 1 minus cosine x. Do they give you cosine x? No. So draw a little triangle. Here's my angle x. Opposite, square root of 15. Hypotenuse, 4. 4 squared is 16. Square root of 15 squared is 15. When I subtract, the difference is 1. And then at the square root of 1 is just 1. Cool? So from there, I get cosine. Cosine of x, let me put it here on the side, is 1/4. So now we know, we can go now. Plus minus square root 1/2 parenthesis 1 minus 1/4. If I have $1 and someone takes away a quarter from me, I now have 75 cents. So plus minus 1/2 3/4. Nothing cancels out, nothing reduces. I'm just going to multiply everything out. Plus minus square root 1 times 3 is 3. 2 times 4 is 8. Plus minus square root of 3 over square root of 8. That reduces to square root of 3 over 2 square root of 2 because 8 is 4 times 2 and the square root of 4 is 2. Are we still okay?
Yeah.
Last step, multiply the top and bottom by square root of 2 over square root of 2. And you get square root of 6 over, and then 2 times 2 is 4. And we look for that answer. Mesa que masa, Flavia? Mesa que masa, mesa que masa. Okay, I'll stop. All right. This one here, recognize that 7 pi over 8 is half of 7 pi over 4. You got to recognize that. Sine half 7 pi over 4. If you take 7 pi over 4 and you multiply by half, you get 7 pi over 8. If you take 7 pi over 4 and you divide by 2, you get 7 pi over 8. So multiply by half and divide by 2 mean the same thing. Are we okay?
So that tells us what?
That we can. This is going to tell me what sine of 7 pi over 8 is, which is half of 7 pi over 4. It's a half angle property. So plus minus square root 1/2 parenthesis 1 minus cosine of 7 pi over 4 equals plus minus square root 1/2 1 minus cosine of 7 pi over 4. Another one at the same time. Square root of 2 over 2. I'm going to turn that 1 into 2 over 2. So plus minus square root 1/2 parenthesis 2 minus square root of 2 all over 2. 2 times 2 is 4. Plus minus square root of 2 minus square root of 2 over square root of 4. 2 times 2 is 4, remember. And the square root of 4 is 2. Now we got to decide positive or negative. This is sine 7 pi over 8. 7 pi over 8 is really close to pi. That's 7/8 of pi. So what quadrant am I at?
First.
No, not the first.
Oh, second.
The second quadrant. It's really close to pi. In the second quadrant, is sine positive or negative?
Positive.
Positive. So the answer is, does it look like C to you? Yeah. Okay, the last one. I put this one in here because you guys were missing this over and over on the exam, either leaving it blank or not even answering it. It's not related to the last question that we did. It's not related to half angles at all. So yeah, I think you did get it. So on this one, you have to choose two angles that add up to 7 pi over 12. And try to choose angles that are perfect on the unit circle. So most that did get it right chose these numbers. 4 plus 3 is 7. And 4 and 12 and 3 and 12, they reduce. So notice 4 goes into 12 3 times. 3 goes into 12 4 times. So this expression here is the same thing as saying sine of pi over 3 plus pi over 4. That's the same thing as saying sine of 7 pi over 12. Do you understand that? Now we're just going to use our composite argument properties. That's our sum angle properties. And I'm going to write sine pi over 3 cosine pi over 4 plus cosine pi over 3. That's a 3, just came out dumb. Sine pi over 4. And the unit circle never goes away, so always know it. Sine of pi over 3. Oh man. Square root of 3 over 2. Sine pi over 3 is like 60 degrees, and the y value is square root of 3 over 2. Cosine pi over 4. Those we should know stone cold. All the pi over 4s have the same x and y value. And a pi over 4, they're both the same. They're both positive. Plus cosine of pi over 3. That has to be a half. And then sine of pi over 4. Square root of 2 over 2. So we just multiply those suckers. So square root of 6 over 4 plus square root of 2 over 4. And there you go. Yay or nay? Okay. We're done, guys. Okay, Kreshmar, do you feel better now? Now we can do it.